everyone, my name is Ryszard. I'm a software engineer with Twizu. And I'm really excited to be here with you today. Thanks to Skyscanner and the festival organizers for having us tonight. We're going to talk about how we had built a machine learning pipeline to mine social data as a startup. The thing about working in a startup is that it's obviously a little bit different to a large corporation. Now, I previously come from JP Morgan. And when you work in a big company, you usually have an existing technology stack, and you iteratively improve probably an established product. At a startup, the pace is much faster. You're bringing a new product to the market. You probably have some early adopters who give you feedback, and you want to be able to iterate on that feedback quickly. And you're quite often starting with a clean slate. So what we're going to do today is talk you through our kind of first-hand experience of developing a pipeline from the ground up. We'll begin by discussing some of the problems that we have to solve when we mine social data. We'll talk through some of the learnings from building our own pipeline, and then we'll discuss briefly an architecture that supports quick development of this kind of pipeline. So let's start by talking about social data. Today, most of the content on the web originates on social media. Take Twitter alone, there are hundreds of millions of tweets being contributed every single day. But a single tweet is such a fleeting thing that unless you're Justin Bieber, it's only ever going to reach the few hundred of your own followers if you're lucky. Now, at Twizu, we think that it's a missed opportunity that this content doesn't have a second life of, outside of, twitter.com. So we have built technology that brings the very best of this content to other parts of the internet. Our customers love showing this content on their own pages because it helps them better engage their own audiences. So we can take a look at one of the companies we work with. OpenTable is one of the world's leading restaurant booking websites. And for each one of their restaurants, like this one, Hakkasan, it's a Cantonese restaurant in Mayfair, London, they have a page. And on this page, they have a social review section where they want to show the very best content that diners have posted on social media, like Twitter or Instagram. Now, if you think about how you'd build this social review section from the scratch, you're probably familiar with Twitter's search endpoint on their API. You might consider putting up some filters against the fire hose and use the restaurant name or the restaurant's Twitter handle as a way of bringing this content in. And then just stream it right in, right? I mean, it sounds fairly simple. It's pretty much where we started. And if you do that, then this is the sort of content you can expect to get back. What I'd like you to do is spend 10 seconds putting yourself in the shoes of an OpenTable user looking to book a restaurant, say, after this talk, and see which bit of this content will be useful to you. Right, so we can see that really, to us, there's only two bits of content here that are useful. We have this tweet from someone saying they've just had the best food of their life at this place, and this pretty cool picture of a salad. And the other stuff is pretty low quality. So we have someone talking about Hakkasan, but it's the wrong location because Hakkasan happens to be a chain. We have this brand advertising the availability of their own products at this location, which is again not of interest. Or we have something completely spammy, like this tweet from Hookup Now, which OpenTable would never want to see on their page. So having identified good content, that's part of the job. The other job is to then rank this content so that when we do display it on OpenTable's page, we know what order to display it in. Now, for the purposes of this slide, I had only showed you 6 tweets, but obviously when you think about syndicating social content across the tens of thousands of restaurants that OpenTable have in their inventory, with hundreds of thousands of tweets that we consume every single day, it's obvious that a heuristics or a human curation-backed approach is not going to scale. So when we thought about how do we automate this process with a machine learning pipeline, we quickly realized it's going to be a tricky trade-off between showing pretty much everything that we have harvested on social media so that the social review section is nicely filled, but obviously risks bad content going through, versus not showing anything at all, so we're safe on the contents quality side of things, but obviously the page looks a little broken, social reviews are empty. Now, you're probably familiar, anyone who's done data science, the recall precision balance is a problem that we all have to solve. What's particularly interesting and fun and challenging about our use case is that, unlike with normal machine learning projects where you would look at social media, analyze some results internally, and any mistakes you make are less apparent to the end user, for us, the results of our machine learning pipeline are streamed directly to OpenTable's millions of users and other customers. So we have to strike this balance really, really well, because otherwise we risk showing irrelevant content, maybe wrong location, or worst of all, a bit of profanity or nudity, or not showing anything at all. And in either way, their own customers are going to call up OpenTable and say, hey guys, your page looks a bit broken. And in the worst case scenario, it's going to cost OpenTable some revenue, and we want to avoid that. So how do we get this balance right? Lots of machine learning. Conceptually, you can think of our pipeline as a funnel. What happens is we begin by harvesting social media, for example, using Twitter's enterprise API endpoint called GNIP. And already at this stage, we're using machine learning to inform the construction of GNIP filters. For example, the choice of a particular search term for a particular restaurant. We take the harvested data set and we push it through a number of components whose job it is to wither this data set down until what's left is good, high-quality content that is safe to display on our customers' pages. Each one of these components is made up of a number of models which have a specific classification task. For example, working out whether the post is from a real user or a brand. We use supervised, unsupervised learning depending on the data that we have, the problem we're trying to solve. I'm not going to go into a lot of detail of that, but if you're interested in hearing more about our machine learning, come find me afterwards. Now, there have been a number of learnings for us building this pipeline. What I'd like to do next is share some of the more practical ones that you can apply in your own work. And the first one is that if you're going to be building something from the ground up, it's super important to get the scoping for your models correct. If you think about the overall task of finding content on social media, it's pretty hard. It's subjective, it's broad. And what we had found good is that when we come to develop a new model, we actually go ahead and tag or label some of the proposed training data ourselves. This gives us a good idea of whether we had defined the problem well. Say we want to build a classifier that looks at an image and tries to answer the question of is this a food image? Some people might look at this and say, yeah, it's a food image because it's got some pancakes in it. Other people would say, no, it's an image of the rock. It just happens to have some food in it. So this would be an example of a badly, too vaguely defined the problem. And if your problem is vaguely defined, you're probably going to struggle to build a model that performs well. So we have found it's hugely beneficial to actually do a little exercise of taking this data ourselves to see if we have struck the boundaries of the problem well. Now, if you're going to be working on a classification task, a supervised learning problem, you probably might go ahead and use a service like Mechanical Turk to find, build yourself a big enough training data set. And what we had found here is that it's super important to investigate the integrity of any data you get out of an external labeling service. It could be they had not defined your problem well enough. It's important to define the features, but also the constraints of what you want Turk to do, because they obviously understand the problem at hand a lot less than you do. But we had actually discovered that there's some abuse of the platform. So what we have here is an example of a simple bot detection algorithm that we had built, which goes through the data sets and looks for unusual activity, like if I have a binary classifications job to do, and I know that the training data should be about 50-50 split between the two labels, and then I see someone completing 7,500 tasks with a really significant skew time and a median time completion of just 1 second, it looks a little fishy. And so we use the feedback mechanism to build ourselves a trustworthy attacker population before we actually use the training data set. This 7,500 tasks is actually maybe a quarter of your training data set, in which case it's obviously going to be affecting the quality of your model. And then lastly, we try to bring value where we think the others haven't solved the problem well. At one point, machine learning pipeline that we had developed needed to understand images really well. And in particular, we're looking to extract text from images and use that text as a feature of a model. So what I've done is I've gone off and seen what other tools exist, and I looked at Google Vision API and passed some data through it. And what I have here is an example of Google Vision API completely falsely identifying a bunch of text in what is otherwise an image of a view out of a restaurant in New York. So the learning here is that there's great tools out there that maybe have worked for other domains, but you really have to make sure that these tools will work well for your own data as well. Now, that's just one side of the story, building models. The other is developing an architecture that supports quick development. What I have here is a very simplified diagram of our architecture, and you can already see that what is conceptually a funnel, kind of like a waterfall process where every tweet that ends up on Open Tables page has to go through one model after the other, is actually implemented as a decentralized, distributed system of these independent machine learning components. And the advantage of them being independent is that it allows us to push data through them to evaluate their performance without having to run the entire pipeline end-to-end, which would be both more costly and also more time-consuming. These individual components sync version attributes to our brain, our data store, and then the gatekeeper can expose some of these attributes to our customers via the serving layer for them to filter on. Now, these components are both containerized deployments running on Kubernetes, which deal with real-time data, as well as clustered distributed jobs that allow us to push an algorithm change or maybe a reference data change through our entire data set. And for those of you who deal with infrastructure, you see this as an example of something called the Lambda architecture. So you'll see that building pipelines for mining social data has a lot of nuances for both data scientists and data engineers. I'd love to talk to you if you have any more questions and find any of this interesting. Thank you.